Okay, so it's 4:30. I know this is like the last talk of the day, and everybody's like, dude, let's just go home, or like, let's go to like the Birds of the Feather talk. But I want to thank you guys for coming to my presentation. I'm super honored. This is my second ever conference presentation. So I'm going to be talking about building a better Kegerator with Raspberry Pi and Sensu. So how many were able to make it out to the workshop yesterday for Sensu? Okay, so there's you. By the way, I was just telling Thomas up here in the front that for those of you who were doing the workshop and you couldn't get the dashboard to start, that was actually a bug in our software that we managed to expose in the middle of like this demo. So I'm cool with it. Like if it means I'm making like a better product, I'm all for it. But yeah, so just know that it wasn't you. Thankfully, it wasn't me. Either it was just for some odd reason reloading any sort of change you made in the config caused the dashboard to seg fault. Fantastic. So, go ahead and switch up. But actually, how if I put the receiver in, I guess? Maybe. It's fine. Cool. So, my name is Aaron Sachs. I am a customer success engineer at Sensu. And so I'm also an avid banjo player. I'm a home brewer, which is the whole reason I'm giving this talk. And if you want to do any hot takes on brewing or monitoring, just at me at asax01 on Twitter. Just quickly before I start, are there any colorblind people in the room? Like, if I use a green laser dot pointer, can you see it?
Well, I have very good promos. Put it up there to see. Yeah, I can see it.
Okay, cool. Just double check.
It's only certain shades.
Gotcha. Okay. Cool. So, and before I get too much into this, how many people know what a Kegerator is? Hopefully the whole room. Okay, cool. I saw a couple hands that didn't get raised, so if you, just for the rest of the presentation, so you know what I'm talking about. When you have beer, you have a keg, right? This is a big gigantic cylinder. You put it in a thing to dispense it, right? If you're at a bar, that means you're stuck up to a line. If you're a home brewer, that means what you actually have to do is create a thing called a Kegerator, which is a combination of a dispensing mechanism and a refrigeration mechanism. Cool. Awesome. So we're all on the same page. So, the project. Right? Every good project has got a good origin story. Mine actually comes from a hatred of glass bottles. How many people have actually homebrewed before? Okay. And you bottle, I'm assuming, so you know I pain. For those who haven't done this before, when you brew and you're a home brewer, typically you work up, if you're like somewhat decent, you start out at like a 5-gallon batch. That means you have approximately 50 glass bottles to sanitize and rinse every single time. So this is painful, right? Because I have to soak them in the bathtub and I have to clean each and every one of them. And that's discounting any sort of broken bottles, or, if you have good friends like I do, who donate bottles to me with the label still on them because they won't strip them themselves, that means I have to do the work, right? So after about 2 years of home brewing, I said, forget this, I need to move to kegging. So I went from this situation to this situation. By the way, there was also another problem I encountered, and that is carbonation control. So when you do beer, right, if you're in this situation, that means you use CO2 or nitrogen if you're making something like a Guinness clone, and that carbonates the beer forcefully, right? I'm forcefully injecting carbon or nitrogen into my beer. If you're bottling, that means you actually have to give the yeast a little extra sugar. You basically quarantine them off in that bottle, and as they're chugging along eating on sugars, they're crapping out alcohol and CO2, right? So that CO2 ends up in like the bottle, but you end up having a situation every now and then where you have a bottle bomb. So my wife was getting sick and tired of 4-foot guys with beer in the kitchen, so it was also kind of like a move to save my marriage. Now, okay, so when you have a keg, though, like I mentioned with the Kegerator, you have to have something to dispense it, right? Because it doesn't do a whole lot of good if it's just sitting in that. Nobody can drink that, right? I can't like walk up to it, pop the top, and like, drink it in this Texas heat. I have to have something to dispense it. So that's why I decided to make this Kegerator. Now, yes, you can go online and buy them, and there's some that have some really nice temperature controls, but because I'm cheap and I need my life, I decided that I was going to do this the most DIY way possible. So I did a build your own kegerator. So here we have a picture of it during construction. I've attached tap handles to the top. I've got my door off. I've got sealant here for sealing some of the holes that I drilled. And this is more or less what it has ended up looking like. Which leads me to some problems. So, the first problem. What does that look like? Anybody? This is conversational, so y'all can talk. I know y'all are tired, but y'all can say something. Anything? Right? So it's freezing, right? Freezing. So this is the problem that I had. Because I used a cheap dorm room refrigerator, what that resulted in was the lack of temperature control that the nice digital Kegerators give you. So my first beer that I decided to do 5 gallons of was this 14% barrel-aged Scotch ale. It's delicious. Like, perfect. The problem was, it froze the first time I put it in the kegerator. So I had the world's biggest alcoholic push pop. I had to wait for it to thaw, and my wife wasn't exactly happy. Yeah, it froze. The whole thing froze because I was like, yes, I like turned this weird little dial inside it. It's called 3. 3 sounds like a good number. It doesn't sound like 7, which was the highest. It was 3. Yeah, 3 froze it. It's actually now on 0, for those that are wondering.
Did it burst the keg?
No, it didn't burst the keg.
Wow.
Right. So, like, I mean, like a normal keg will hold something like 6.5 gallons. So if you brew a 5 gallon batch, it gives you a little bit of headroom to kind of whittle around with.
You have a slim, please.
Yeah, 40 kegs. So
I thought you had like half frozen and the rest really, really strong beer. So the frozen part,
Yeah.
separated the
Right. So like inside a keg, like corny keg, there's a siphon tube, right? So it pulls from the bottom. So that basically means I couldn't get anything that was up at the top. So I had this other problem, which I didn't think was much of a problem. My wife will tell you, however, that because I leave the refrigerator door open all the time, yes, it's a problem. And this basically results in, like, if I leave the kegerator door open, I've got a nice little AC unit in the middle of my kitchen that is cooling this section down and running up my electricity bill, which during the summer isn't great. So I wanted to monitor that and be able to fix that as well. Ooh, my holy grail. Right here. Not the phone, that's not what I'm aiming for. So let me rephrase this. Knowing how much beer I have left. How many people have ever had somebody come over and you thought you had enough, beverages to entertain them, and it turns out you had like 2 beers in the fridge and you're like, I'm sorry, the last one's a PBR. So when I would be dispensing my beer, I would end up in this situation. I would only know that the beer was the keg really was almost empty because I got a mug full of foam. And it was kind of embarrassing having people come over and be like, yeah, I've got some like great award-winning homebrew, and then, oh, okay. So I wanted to fix that. That is about, by the way, this far away from being fixed, but what I will end up showing you today is not how I'm just monitoring a kegerator using Sensu, but how I'm using Sensu to monitor IoT sensors. So, you'll see this in the context of beer, but start thinking, like, as we walk through the rest of the presentation, about how this might look a little bit more broadly. Like, I'm using a contact sensor. What else can contact sensors be attached to? Doors, cupboards, that sort of thing. I'm using a temperature sensor. You can use a temperature sensor and say, like, the middle of your house, something like that. So you can use Sensu not just to monitor a kegerator, even though that's the context of the presentation, you can use it to monitor other things. So, let's keep going. The solution, Raspberry Pi and Sensu. Cool, yes. Now, this project is about a year old for me. I initially started thinking about, well, hey, I really want to get better at coding. So I'm gonna code this whole thing. It was a bad idea, right? How many people have started a project only to realize, like, it's too massive for me to undertake? Yeah. So I needed to break it down. So I used a Raspberry Pi and Sensu, plus the temperature sensor. This is a DS18B20, which you can get off of Adafruit. By the way, there are links at the end of this presentation to buy all the materials. You can see the cost of everything, and I also have a walkthrough and some series of blog articles that you can use to kind of roll it around. I'm also using this contact sensor. It's a simple reed switch. I'm using these. Anybody know what these are? Not water. They are load cells. Okay, so if you take apart your, so if you take apart your bathroom scale, you'll find 4 of these that are attached to something like this. This is an open scale board from SparkFun. Basically, what ends up happening is you wire 4 of these together. That board takes the average of the pressure that's on all 4 of those sensors and gives you a weight. So, I just know how a bathroom scale works.
Why do you need 4 instead of 1?
Because you do what's called a weak bridge configuration, which, you can dig into this on SparkFun. They'll explain all the physics and like electrical stuff behind it. But yeah, so it just gives you a better reading. You can use other bars. Like I went through 2 or 3 other strain gauges that didn't quite work. And I thought initially, because these are the cheapest things on SparkFun, they can't possibly be reliable. Well, the cheapest thing happened to work. Cool. So let's talk about the build out. Again, so this is a Raspberry Pi. I'm using, and I'll show you a picture here in a moment. I'm using a Smarty case enclosure. You can get these for fairly cheap off of Smarty Case's site. I've got a 7-inch LCD screen because I can display my cool graphs with Sensu or InfluxDB on the screen there. I've got 4 of these load cells, open scale board, the temp sensor, and the contact sensor. They're wired.
Which Raspberry Pi are you using? 2?
3D Plus. Yeah, the latest model. So it practically is looking like this. So here's what those screen load cells are kind of wired like. I'll show you a wiring diagram here in a second.
Actually,
50 kilograms. Yeah. So basically I've got, because I'm a good old DIY kind of guy, I got myself a plywood scale. Redneck engineering at its finest. So there's 2 of these plywood scales that will actually sit underneath the kegs and monitor them. They communicate over a serial connection, which you'll see here in a moment. And I'm still working on the Sensu plugin that's going to communicate via the serial connection, but you can see that repo here that I'll post a link to at the end of the slide. So these nice little red, yellow, blue wires are the temperature sensor. They're connected to a 4700 ohm resistor. And then I've got my contact sensor there with the white wires. And this is just because I didn't feel like attaching everything to the Raspberry Pi. I'm using a cobbler attachment, which ends up looking something to the effect of this. So that's the temperature sensor. Sorry, Fritzing didn't have the nice, like, long wires. But that actually it's mounted inside of the refrigerator. That contact sensor right there is mounted to the door. And then I've got those 4 load cells that are connected in a weak bridge configuration. You can again dig into this on SparkFun, that are talking over a USB serial connection. So, it is nice, it is pretty. It looks like this. This is the semi-finished product that I ended up with. So here's my Kegerator, right? I've got my nice little Raspberry Pi and its enclosure. The plywood scale is currently measuring a thing of hot chocolate for a reference weight until I can get everything just perfect. But ultimately, that will sit inside of the Kegerator, and that's kind of what it looks like. So what you can't see here is that I got Bushiwa, which is the dashboard for Sensu, and I'll go over that in a moment, displaying some metrics there. So monitoring it all. So before yesterday, I noticed that there were some folks who hadn't heard of Sensu before. How many people, like, Sensu is just a brand new thing for you? Cool. Awesome. Okay, so Sensu is monitoring software. This is our marketing line. It is a proposable monitoring framework aimed at obviating the need to rebuild custom monitoring solutions. The English version of that, and not the marketing thing that Matt Broberg tells me to say, is that we write software that monitors stuff so you don't have to do it from scratch. Cool, pretty simple to understand. And we have two products. We have our core product. So this is open core. That means, Sophia, if you decided that, you know, I wanted to make Sensu do this thing, whatever you decide that thing is, tomorrow, you could go and like download the repo, make a branch, make a change, bump it up, and cool, we're done. Right? So anybody in this room can make changes to Sensu core. Sensu Enterprise is our more opinionated product, and I'm not plugging that. I will say it's got some kind of nice features, and plus you get to work with me. But you don't have to work with me. You can use Sensu Core, and you can still accomplish all the monitoring things you would normally do inside of Enterprise. Enterprise just makes it a little bit slicker. So, why Sensu? Sensu's super, super, super flexible. So yesterday I did a workshop that discussed, hey, like you can monitor our website, right? So we wrote a custom check, filter, and handler. And Sensu was originally designed to monitor applications and hardware and that sort of thing. But the whole reason I'm here is because it's flexible, right? Like I can monitor a Raspberry Pi with some IoT sensors. So I can, like, as long as I can write a script to do something, Sensu can monitor that. So it's also easy to write things for Sensu. So Sensu is a Ruby product. That doesn't mean it like a plugin. So this concept of a plugin, like if you haven't heard that before, it just simply means Sensu comes with some base functionality. I install some plugins that makes it do whatever I want it to do. If that's monitor OpenStack, if that's monitor AWS, if that's monitoring like a Mesos cluster, I can make Sensu do that. So the plugins are super easy to write. I mentioned earlier that yeah, I wanted to write like a super cool dashboard and a super cool thing that would monitor all this stuff. I don't come from a coding background. I'm pretty much a code newbie. But I was actually able to write some plugins that do this. So if that tells you anything, somebody who's a noob in Ruby can actually write a set of plugins fairly easily. So Sensu also works on any Linux system. It works on Windows. It also works on Solaris, AIX, works on OS X. So if you work in an organization where you want to monitor like Mac Minis or laptops, you can do that with Sensu. Okay. Yeah. So here's how Sensu works, and this is kind of a let's call it a logical overview. So I'm sure everybody's familiar with the client-server architecture. Sensu fits into that mold somewhat. But so we have a client, right? So this Sensu client, here agent. So it's an agent that I install and something that I want monitored. I have an agent, I have a server, right? So my server is primarily responsible for telling the client, I need some data, please. The client says, yes, server, I'm going to send you some data. The way that this all works is they connect to what we call a transport mechanism or a message bus. So this is RabbitMQ. And so I point my server at my RabbitMQ instance, I point my client at my RabbitMQ instance, and all of a sudden they're able to talk. This is like having a couple of therapy, and the RabbitMQ is kind of like a therapist. I also have a data store mechanism. What this does is this takes, so when a client runs a check, it either sends out a 0 or 1 or 2. Okay? It's either okay, I'm in a warning state, or I'm in a critical state. That 0, 1, or 2 gets stored here. We also have the concept of silencing checks. So if I'm doing maintenance, I kind of want things to be quiet. Those get stored in Redis. I also have an API, and so this API, of course, is just a programmatic way of interacting with my Sensu deployment. Pretty simple. One thing that I did not mention here is that we have a dashboard called Uchiwa, which if you were in the workshop yesterday, you saw it crash. But really what Uchiwa is designed to do is to provide a graphical way to interact with Sensu. So all of that works and then sends you, the end user, something, right? So if it's okay, it's basically saying, hey, my systems are okay, excellent, we're doing great. Or it'll say, everything is on fire, wake your butt up and fix it. So this is kind of what it practically looks like in the case of my Kegerator. So I have a nice little Raspberry Pi. I am talking wirelessly, because the Raspberry Pis have Wi-Fi in them, to a Sensu instance that I have running at my house. So this consists of RabbitMQ, Redis, the Sensu server, the Sensu API, and Uchiwa. And it gives me this nice little dashboard.
What's your memory footprint for all that?
memory footprint. So you can actually run all of that. If it's like fairly, like if you're not doing a whole lot of checks, like I think I have probably like 10 or so things monitored in my house. You can run it on like 1 year RAM easily. Like it's not that doesn't require a lot. If you are running a production instance of Sensu, you probably want a cluster. You probably want something that's got 32 gigs, pretty beefy, especially if you're doing thousands and thousands and thousands of checks. You want something pretty heavy. But yeah, for something like home monitoring, there's actually a repo that I'll link to at the end of the presentation that spins up a Vagrant box. If you're not familiar with Vagrant, it's just a wrapper around VirtualBox. It's just a little 2 gig instance that you can like mess around and do things with and kind of be used to using Sensu. So Sensu also has these 4 building blocks, which if you were in the presentation yesterday, these should look super familiar. So these building blocks are checks, filters, mutators, and handlers. Let me do the plain English description of those. Checks, gather data. Filters, allow the important data through, right? I don't want to get paged in the middle of the night for like another team's thing. Forget about it. Mutators, change my data. So Sensu, by default, our community plugins are standardized on outputting Graphite plain text formatted data. If you're familiar with Graphite, not a problem. But say your company is using something like InfluxDB or another software that doesn't exactly understand Graphite's format, a mutator will change that into whatever you need it to be. There's also this handler. Handler is the thing that says, everything is on fire, wake up please. So, if that's Slack, if it's a phone call, it's pager duty, whatever, that's what a handler does. So the checks. The things that are making this whole Raspberry Pi Kegerator system work are this custom plugin that I've written. So it consists of 2 libraries, our GPIO library, which is basically a clone of like Python's GPIO library, if you're familiar with that. And then the Sensu plugin library. So this basically provides all the like nice check features where I can specify any sort of like flags or config options that I want. And then the plugin itself consists of these executables. So I have temperature checks, I have both a metric check and a status check. What I mean by that is a metric check is basically just getting like the data. So in Sensu we have this concept of just data with no particular context. Right, if I want to graph it in Influx or Graphite or my OpenTSDB instance, I can do that. The status checks are like up or down. So in this case, for the temperature, I have a check that says, hey, if it's above 45 degrees, let's emit a warning. If it's above 60 degrees, you better go check and make sure that the Kegerator didn't blow up. I also have this contact sensor status. So this is like if the door's left open for too long, rather than me having to scream across the house to my wife and be like, Ashley, please don't close the door. Like, I can actually get the notification myself, so it saves my wife a little bit of annoyance instead. And then I also have the beer amount metric and status checks that are in progress. Not that close. So the demo. I'm sure you want to see everything kind of like working, right? I'm going to flip over. So this should look familiar. This is like the same Uchiwa dashboard that I was using yesterday. Let me blow this up just here. Then on as that. So I have my calling it Keg Pi, branding right there. So when I click on the client, right? So inside of Uchiwa, I have events that get emitted. I have clients. I can see whatever checks I've specified. I have any checks are silenced, for example. I can have those show up. We have these concept of stashes, so this is just custom key value pairs. I won't dig into them a whole lot. We also have aggregates. So for the folks who are running large server farms, let's say if you've got like 50 web servers, right? It doesn't matter that 2 of them are down, but you want to know if like 48 of them are down, that's an aggregate. So we provide this ability to say, hey, don't just do the check on the individual things, but also do the check in like the service as a whole. So that's an aggregate check. We have this concept of the data center. This is something I explained yesterday in the presentation. So Sensu's concept of a data center is kind of a little bit of a loaded term. It's not a physical data center, it's just an API endpoint. So what I can do with GWAP or the Sensu Enterprise Dashboard is basically, in my configuration, provide like the location, so the IP address and ports of all those disparate Sensu API endpoints, and then have a single pane of glass inside of my dashboard. And I can show you what that looks like as well. But so, KPI, I've got some information here, the name, IP, any events that are currently happening, the data center name, the version that I'm running, and then when the last check was. Cool. So I've got my keep alive, and since we have this concept of keep alive, it's a heartbeat that basically tells the Sensu server instance that yes, I'm alive. This is the only check that you get out of the box. These three other checks, though, are the ones that I've written, and the ones that I think are like pretty cool because of the work, right? So I have a check temperature check. So what I actually care about is, where's my output? Right here. Current temp, 36.95 Fahrenheit. Yeah, I want to start my beer at that. It's not freezing. I'm not running into that first problem. This is good. I can also embed graphs, which I'll show you that on the metrics instead, because that's actually pointing at a different instance right there. So I get metrics, right? So here I am. Graphs. So I had my wife open the Kegerator door, just open it for a few minutes earlier, so you can see that like basically what this line represents is at the peaks, that is my compressor kicking on the refrigerator, so it cools down and the compressor kicks off, kicks it back on again. We continue on that trend until I have my wife open the door and oh my gosh, I got a spike, I get alerts, I get emails, I get sirens, whatever, tell me, oh my gosh, like things are happening, you need to figure this out. So just a quick note, so from the diagram earlier, we have the Redis component of our installation. This is all that Redis stores right here. And it stores 21 status results, and what this does in terms is detect flat detection. So like if I've got a load balancer or a web server that's doing something funky, it'll basically say, hey, it looks like it's flapping, like you don't need to do anything to it. So then we've got the contact sensor. So this is the one that my wife actually cares about. And so this just basically tells me, hey, cool, the contact sensor is closed. If it's open, it turns red. It's going to be a bunch of alerts. Now, for the future of what I'm writing, there will be something that gives me some nice pretty graphs and tells me, you have like 8 pounds of beer left, which is roughly equivalent to 1 US gallon. You should probably consider brewing this weekend. So that's eventually where I want to get with this. That's kind of how Sensu works on a Raspberry Pi. So what I'll do now is just give you some resources quick. So if you want the slides for this to kind of get a better idea of the diagram, you can go to github.com/a-01/txlf18. That'll get you both the slides from yesterday and the slides from today. That will also get you a full materials list that tells you exactly how much I spent on this project. It's kind of embarrassing because I could have just bought something offline and it would work fine, but it's not over-engineered, it's not done right, correct? There's also kind of a walkthrough of how to put it all together, and how to wire things. The slides themselves are that KPI TXLF18 link. The training Vagrant link right there actually will take you to what we used yesterday in the workshop. So if you feel like, well, hey, the Sensu thing looks kind of cool, maybe I want to work through it on my own, that will actually, if you go into the Intro to Sensu workshop directory, there's a Vagrant file, it spins up a box, and it will get you a fully functioning Sensu instance, along with Graphite, so you can do cool graphing stuff. And then we also have docs.sensu.io, which is where me and my team live most of the day, so we're writing a lot of documentation. Specifically, if you want guides on how to use SNMP with Sensu, or if you want to learn how to better secure a RabbitMQ instance, that lives there. And then there's slack.sensu.io, which I know the joke from yesterday, everybody's like, oh my God, not another Slack channel, please make it go away. But, our Slack channel is actually pretty active. There's a lot of great people in there. And so if you ever have any questions, that's a fantastic resource. So, do some questions. Yeah, Thomas.
Have you considered putting like a temperature controller on there too? So instead of doing the 7 to 8, you crank that thing to full, and then just have the temperature controller shut it on and off.
Yeah, so there's a lot of like external things that you can buy. Basically, like you plug the Kegerator into this little box, and you hook the temperature sensor, which by the way is the DS18B20. It's literally the exact same thing I'm using, and that will actually kick it off. So I've thought about that. I haven't gotten there yet.
Actually, you just need a power switch. I mean, a control power switch.
Yeah. That's what this little box. Like, they sell boxes specifically for Kegerators that do that thing.
Yeah.
So it's been fun. Yeah.
What kind of notifications can you set up for it, other than just like basic email? Maybe like Telegram or like other messaging services?
Yeah. So you can do email. You can do Slack. You can do IRC. You can do PagerDuty notifications. If you're using PagerDuty, you can use HipChat. Like basically, if you go to, and actually I think I can do this. I can figure out my mouses. So if you go to github.com/Sensu plugins. So this is our plugins organization on GitHub. It has hundreds of repos. If you can't find something in there that does what you want to do, it's super easy to write. We actually provide either Ruby skeleton or Python skeleton. So that's a great thing about Sensu is you don't have to write it in Ruby. You can write it in Python. God forbid you write it in like Bash or Perl or something. You can do Golang. You can do whatever language as long as it emits a 0, 1, or 2. That's all Sensu cares about. Which, yeah, we talked about it being like a composable monitoring framework. But I think one of my friends, Brandon, who's here today, the light went on for him when he realized, oh, Sensu just monitors scripts. If you can write scripts to do something and it does 0, 1, or 2, like, that's it. But yeah, I mean, I imagine there might be something for Telegram or, I know there's an SMS handler for sure. Yeah.
Another question, you're talking about the 0, 1, and 2, yet you're monitoring something which is a temperature, so that seems to be another set of data somehow, right?
Right. So with the plugin libraries, you kind of define what that means. So like if you say a warning, right? Like the plugin library has the concept of a warning inside of it. So like if I specify for example, if I go to check itself, so you can see there, like I have the -W flag. This is just the warning for the degrees. In that library, like I can basically say what I mean by a warning or what I mean by a critical event. So like it kind of gets, there's some like hand wavy stuff that happens in the library that makes it so like I don't have to say, well, this other data that isn't a 0, 1, or 2 translates to a 0, 1, or 2. Does that make sense?
Yeah, I just was wondering where that data, obviously, does that data just get fed into Graphite, or does it get stored? So you're talking about Redis, who's only storing 0, 1, and 2.
Right. But you're talking about the difference between a return value and the string that it spits out at the end, which
Right.
is your output, which is where you're actually getting the temperature.
Right. Yeah, like,
So obviously you have a way to graph this because you pass it into Graphite, right?
right. So this one,
Graphite database, I guess that's where you pass that data.
so what happens there is like, so that's so this is the metric, right? So this is the metric data. So this is the actual output of it, right? So this is not actually emitting a 0, 1, or 2. Like metric checks don't have that context of a critical warning or or an okay event. It's just shipped off. So because like Graphite, for example, it wants this particular value for the host name, it wants the actual thing, and it wants a timestamp. That's what that plugin library will do.
Okay, well, I get it. I don't see how that fits in your architecture diagram, but maybe I missed it.
There's
Well,
two different types of checks.
Yeah, I get there's two types of checks, I just didn't see it on the diagram.
Oh, yeah. I mean, like, graphite is completely optional. Like, I mean, you don't have to have graphite. Like, you don't. The core bits of Sensu are the Sensu server, the Sensu client, API, Redis, and Rapid, right? So, like, any other external application you want to use to say graph the data like graphite is like completely up to you. Good question.
Maybe we can talk about that.
Yeah.
So is the servers then like pulling your Raspberry Pi over the network?
So what Sensu has this concept of either pub sub checks. So if you don't know what pub sub means, it's publish and subscribe, or I have what's called a standalone check. So the way that this works is, so when I point my Raspberry Pi and the Sensu server at RabbitMQ, what ends up happening is the Raspberry Pi client configuration, which I believe you can see here. Yeah, okay. So you can see the subscriptions, right? So I specified KPI as a subscription. So my checks have that same, like in the definition, it says KPI under subscribers. So anything that connects to RabbitMQ that has that subscription, it gets that check. So basically what ends up happening is like the Sensu server says, hey, anything with the subscription of KPI, do this thing. And then so the Raspberry Pi goes, okay, I have that, here's the data. Like you can also do more of a kind of push model, right? So that would be like standalone. So a standalone check. Standalone clients and checks won't actually, the clients will show up in the dashboard, but the checks themselves won't, because it's not a server task. So because Uchiwa actually is looking at the server and the API processes for the information, like it doesn't have an understanding of like what's going on in the client. Because Uchiwa, rather the API only ever communicates with Redis. So because the Raspberry Pi isn't communicating with Redis, it doesn't really know like what's going on there. Yeah.
So in regards to the weight deal, the first question is how are you communicating with that USB connected aggregator that determines the weight?
How am I communicating with it?
Yeah.
Right. So it's just a serial connection. So when you hook that board up to the Raspberry Pi, right, it opens up like a serial connection. This is usually like TTY.
Okay, so it creates a virtual server device.
Yeah. So it's like
TTY USB 0 or something.
Yeah, USB 0, USB 1, because they're OB2, they're pulling, a couple of different ones out of the
So
bowl.
theoretically, you plug in as many as you want.
Right. Like that's a cool thing. Like if you're, say, like an aspiring, let's say, small brewery or small.
I'm actually going to build something like this for a brewery, so that's why.
Sweet. Yeah. So I mean, if you have a USB hub.
And with the digital tap board, it has real time.
Yeah.
Gateway.
Yeah. So you can use that, and like it'll do it. Which is kind of what I'm aiming for as well.
That's why I was interested in the way you've been doing it. And then what is it that you're trying to overcome now to get that thing?
So right now, there's a couple different ways of doing communication on like the weight sensors. You can get what's called an amplifier board, and basically what happens is like if you're using a strain gauge, the difference in like pressure is so minimal that like if I plug it in directly to the Raspberry Pi is like just kind of staring off into space going, I found something. Right, so the amplifier board basically says, hey, let's take the signal and actually make it something that the Raspberry Pi can read. So you can do that via like an HX711 board, which kind of works okay, but the OpenScale board has that built in, and then is also using like like an Arduino board with some code already built in to do all the weight stuff. So it just kind of stays to the household.
Simply just a voltage fluctuation in the USB?
No, it's like,
I can actually answer that.
yeah.
Raspberry Pi has a data basic on sensors.
Right.
So if you use an Arduino or Intel or something like that, it's their issue.
Yeah, but that external board is plugged on the weight sensor,
Right.
and that's translating all that analog data
Right.
to a digital signal to go back to the
Yeah, and if you get one of these boards, like what it ends up looking like, which I might be able to show. Let's check it out. Let's see. Yep. So you can get into this board pretty easily. So it does this thing, right? So here's your
Load a special driver for that, or is it just?
no, you just natively pulls it, right? So you like, for example, like this is the options that like the Arduino code gives you. So the challenge right now for me is being able to pull what you see here under readings, because like when you do like the initial pull using the I think it's like Ruby serial library, it'll give you all of that. And so initially I was like, oh hey, like let me just try and get this bit. So you basically tell that library, hey, I want you to only read like this many bytes.
You just come in as one big string with line.
Yeah. And so like what ends up happening, like my initial attempt was, well, hey, let's like just try and split that into an array and just access like those two particular elements of that array. And it doesn't work because like the initial read brings in all of this bit and like it shows up as like blank. So it's basically just overcoming that, and being a new dad, I haven't had too terribly much time to like
So it's just parsing a multi-line string, that's.
Yeah.
But if you can get that data.
Yeah, you have to do this weirdness with
I like the way that works.
you have to do this thing of like inserting a character to get a reading.
Oh,
So that's another thing, like the library requires you to insert this character, and then you get the return value. So like, again, once you get past that initial block up top, like then you can get that stuff pretty easily and just you basically send a character and you get the return value and like it's done. So like, for me, it's just a matter of like, having a few hours.
I thought for all that, so I just said,
Yeah, like the PySerial library will do that same thing. Because I'm trying to work with some Ruby and whatever Ruby product. Yeah, I know. Don't judge me too harshly, guys. Yeah.
I have a large garden with about 200 plants, a couple hundred in the soil, and a couple hundred in buckets, and I have to water them, and it's really warm, and I've often been thinking about trying to automate that in some way. I have a rainwater collection system, and I've got some pumps, and I've got some hoses and wires, and but I don't have any electronics. And I do have some Arduinos, and I fooled around with that. And I've also priced out what are the sensors for servos and valves and things. And I thought, well, it's unbelievably ridiculous to think that I'm going to automate this system.
Right.
Because the cost per plant would be more than what it produces.
Right. I mean,
But that's not what I want you to
the cost for this project versus like what I don't make anything here. Right. I should have just like literally walked across the street to HED and said, to hell with it, let's just be done.
I'm just curious if you know of any place I could look maybe for somebody who has maybe played around with it a little bit to get some sense of if I wanted to play around with it a little bit, not reinvent the wheel. Are there places where, I maybe make it work for half a dozen plants in my house, and then maybe, because I've been maybe saving some bits up that I might be able to make my own valves and mounts, so I wouldn't have to spend $7.95 at Spark Fund per plant.
Yeah.
I'm sorry, so first I do a lot of maker stuff, that's why. And I actually do it on my side products. So including in my office and things like that. So like the sensors are $5. Arduino is $10. Or if you want a fancy one like one time where you do IoT stuff, out of the box, it's $20. The sensors themselves, like I say, $5 or you can make your own. You can literally take 2 straws, wrap some copper tape around it, put a resistor and connect it to the analog pin, and be able to measure your sensor enough with that's resistance-based methods. It can be as difficult and complex as you want it to be, or as easy and DIY and cheap as you want it to be. You control your valves with regular servos, like cheap servos. The easiest thing I can tell you to do, hop on YouTube and just type in automated garden work. It will blow your mind.
I mean, the like time is up, but like it's a good discussion, right? Like I thought about that before. But before we get like, maybe you want to like, maybe we can chat afterwards. Okay, cool. So time is up, but again, let me flip back to the resources here. So if you guys enjoyed this, like feel free, hit up the slides. Take a whack at like see, Sensu might be right for you, like if it's a personal home project, you can do it pretty easily on like any server, right? Like, or like if you have a desktop, Vagrant, you're done, like it's cool. But yeah, other than that, cheers guys, and thanks so much.